Hi, welcome to section 10.5, domain of linear functions. Now in the title, I will talk about finding domain within only linear functions. I will also cover rational functions, and later on I will cover other type of functions besides linear. Now, the objectives for this section is determine x values that exist within the domain in each given function, whether it's linear, rational, quadratic, or any other type. But mostly we're just going to cover linear and rational for the time being. The second objective, exclude x values that makes a function undefined. You will have an example which I will explain in depth about making a function undefined. And the third objective is writing the domain in interval notation. Most of the time we'll be using interval notation, but I will also cover inequality notation and set builder notation to be familiar with all forms for domain. And it'll be the same concept if you were doing for range. For the first example, determine the domain of the given function. We have f of x equals negative 4x plus 7. Now, the notation is f of x, but you can also rewrite it in slope-intercept form, which most are familiar with. So instead of f of x, you probably notice or are familiar with y equal negative 4x plus 7. So in this function, you have to determine what x values that you could plug into x, and then it will come out a y value while it's not undefined. So for a linear function, it's going to be very simple. A linear function is a straight line that you see on a graph. Whether it's a positive graph, it's going to be continuous going left and right, or a negative graph, same thing going continuously left or right. So by the term that the graph is going to continuous to the left and to the right, that means that it's going to cover all x values. So that means that there's no specific or limited x values that is provided for this linear function. So as I was saying, there's no limited. That means that you could basically use all x values within this linear function. So again, it's a linear function that there's no limitation for the x values. So again, I describe this as a linear function. So when you're trying to identify the domain, so the first thing I'm going to identify is the interval notation. So for interval notation, we're just simply going to write domain. And interval usually involved with parentheses and brackets, just like how I described in 10.1 and 10.4. So if it's all real numbers, that means that it would go from negative infinity to positive infinity. So you would write it starting with the lowest value, in this case negative infinity, comma, positive infinity, or just infinity. And then since we are using infinities, we always use parentheses. Now this is interval notation. So let me input this here. Interval notation. Now the next one is the inequality notation. So inequality uses the inequality sign. Now this one, if it's all real numbers, meaning if it's from negative infinity to positive infinity, so that means that when I write my domain, and again, I'm going to be using the letter D to symbolize domain, I would just simply write D. Then for the symbol of all real numbers, is 2 lines and then an R. This symbol represents all real numbers for inequality notation. Now, the last notation I mentioned is the set builder. Like this. A set builder is very similar to inequality notation. It will use the inequality symbols. So when we're working with domain, we use the symbol X for the X values, then a vertical line stating that X is all real numbers. So that's the only thing I could write, and then I'll just close it up with these brackets. So here's the examples on how to identify domain when it's all real numbers for interval notation, inequality notation, and set builder notation. Now in the next example that I will go over, there will be a specific limitation on domain, and you will see the correlation between interval notation, inequality notation, and set builder notation. But as I stated before, when you have a linear function, as I said, in these typical example of the graphs, they have arrows at the end. That means that they're continuous. So they're going to go on forever to the left side and forever to the right side. Hence, if you look at my interval notation for domain, if it goes forever to the left, the symbol is negative infinity. If it goes forever to the right, the symbol is infinity or positive infinity, but also known as all real numbers. That means that any x values can be used in this function for the domain. So for all types of linear function, and to determine if it's a linear function is most of the time is when the exponent on the x is 1. So using this example, linear function is usually where the exponent on the x is 1. Now, you may have been familiar with quadratic function where it has an exponent of 2. So that's a quadratic type, not a linear type. But for linear function, when you have an exponent of 1 where it's not in the denominator, so I repeat, when the x is not in the denominator, but in the numerator, then it would be considered as a linear function. Then basically the answer for domain is negative infinity to infinity for interval notation. For inequality, all real numbers, and then this would be your solution for set builder notation.